I want to write, I want to find the step response for this circuit. Step response for this. Or we can call it as C, we can call it as R, we can call it as V. Switch is there. The switch is closed at t equal to 0. Let us assume that initially no charge in the capacitor. At t equal to 0, it is closed. That's why it is a step response. Step response we are applying. We are finding a step response of the voltage across the capacitor or current through the capacitor. Let us find the response is IC of t that we want to find. Write K at t equal to 0 plus at t equal to 0 plus, write the KVL. If you write KVL, let us start from A, B, C, D, A. Consider the loop A, B, C, D, A. Consider the loop A, B, C, D, A. If we travel from A to B, increase in voltage of 5 volt. So V, generally you will write V, volt. Let us assume that current through that circuit is I of t. I of t. What is the potential drop across the resistance? Minus R I of t. What is the drop across the capacitor? Minus. What is the voltage across capacitor? 1 by C integral of I of t dt. That's why we have to put 1 by C integral of I of t dt. I of t dt. From minus infinity to t. Because t, up to t we are writing the expression equal to 0. This is integral differential equation. This is called a what? Integral differential equation. Because integral is involved. If you differentiate once, it will be a differential equation. It will be a differential equation. On the other hand, if you write for inductor, what you will get? Suppose instead of this capacitor, one inductor is there. You will write expression for voltage. If you write voltage, expression for voltage, what you will get? What you will get? Plus V minus R I of t minus L di by dt. L di by dt equal to 0. What is the order of the differential equation? Instead of capacitor, if inductor is there, we wrote this. What is the order of this differential equation? First order. First order differential equation. Any energy storage element, whatever may be the energy storage element, any energy storage element, if you write equation, it will be a differential equation. It will be a differential equation, whether it is mechanical system or electrical system or biological system, whatever may be the system. If you write equation for its dynamics, it will be differential equation. This is also a differential equation of first order. Because if you differentiate one time on both sides, what you will get? dV by dt minus R di by dt minus I of t divided by C equal to 0. It is also a first order differential equation. First order a differential equation. So, but because of integration is involved, that can be called as integral differential equation. Integral differential equation. That's why the mathematics you are troubled to solve differential equation. Any system, if you want to obtain the mathematical model of any system, it will be a differential equation only. What is mathematical model? What is mathematical model of this circuit? Here we are finding, suppose you are taking this circuit. You are taking this circuit. I am asking you, what is the current through that circuit? Are you applying 5 volt and checking what is the current you are measuring? Are you telling? No. What you are doing, plus 5 minus I of t, I 5 equal to 0. Therefore, 5 equal to 5I. Therefore, I equal to 5 divided by 5 equal to 1 ampere. This equation is called mathematical model of that circuit. Mathematical model of that circuit. If it is resistance only, means it is algebraic equation. Resistance only means it is no energy storage element. That's why it is algebraic equation. Algebraic equation. If capacitor, if inductor or capacitor is involved, it becomes differential equation. In the world, no element is without storing energy. Everything absorbs energy. Everything absorbs energy. That's why if you obtain the mathematical model, then it will be a differential equation. If you know this equation, then we can find theoretically what is the current through that, what is the nature of current, what is the transient response, what is steady state response. Everything you are finding from the mathematical equation. Actually, what you are doing, you are applying 5 volt in the mathematical equation. You are applying 5 volt in the mathematically, you are applying 5 volt to the mathematical equation. Then we can say that it is also a system, but it is mathematical system. It is mathematical system or mathematical model of the given system. So if you write any equation for a given system, so mathematical model means mathematically express the circuit, mathematically express the system, mathematically writing some equation for the system, for its behavior. The mathematical model represents the behavior of the circuit. Mathematical model represents the behavior of the any system, whether it is electrical or mechanical or biological, whatever it may be. If you write that behavior of the system in terms of equation, then it is called a mathematical model of the system. It is model. It is model of the system. If you know that, you can simulate. Simulation means what? Huh? Meaning? No, I am not asking what is simulation. Simulation, mathematical model, if you know, you can find the current. Am I correct or not? Finding mathematically current is called simulation. But you are thinking that if you sit in front of computer and if you put something, that is called simulation. Simulation means mathematically finding the result. That is called simulation. Computer means it can do very fast. That's why you are using computer. That is called computer simulation. So mathematics class is called simulation. Mathematically, you are finding the output. That is called simulation. You are not actually doing the experiment. You are simulating. Here also we are doing simulation. We are finding current. Mathematically, we are assuming that this much voltage. What is the current? That is called simulation. Simulation means from the equation, we are finding the result or response. Finding the response analytically called simulation. Finding the response analytically is called simulation. So here, what and all we are doing in circuit theory is called simulation. We are simulating the circuits. So the differential equation has to be solved to find the response. Am I correct or not? Here, if you want to find I, you cannot find I because it is a differential equation. di by dt, but I want I of t. If I want I of t means I have to integrate, then only I can find. That is called solution of differential equation. That you studied in mathematics, how in time domain analysis, what you will do, you will find a complementary function and particular integral. Complementary function and particular integral for differential equations. If you have some input forcing function is there, then you will have a particular integral. If no forcing function, for that, if you are simulating, means that is called only complementary function. If you take left hand side only and you are finding some solution, is called complementary function. If you add a complementary function and particular integral, you will get complete solution. It means what? For this, what is the solution mathematically? I of t equal to what? If you find I of t, that is called a solution of differential equation. That's why you are troubled in mathematics class to find solution for differential equation. All the system in the world are differential equations. That's why the mathematicians spent the entire 18th century to solve differential equations. So always mathematics will find the result in advance. Algebra is zeros and ones are found in which century? 18th century. But we are having the device now. Whatever mathematics finding now, you will get the device another 200 years later. So mathematically you will find now. Simulation now. Mathematically finding means you are simulating now. Okay. The differential, if you solve the differential equation, you will get the result. The solution can be done in two ways. One is called time domain analysis. Time domain analysis. You will be analysis. You will be asked to find complementary function and particular integral in time domain. It's very difficult. But solving a algebraic equation is very simple. Algebraic equation means you will multiply this equation, that equation by number, and you will subtract and will find the variables. Suppose two variables are there, two equations are there, you need two equations. Two variables are there means you need two equations to find that. Algebraic means just multiplication and addition, subtraction, you will get the variables. Suppose I am having 4x plus 5y equal to 7, 6x plus 8y equal to 9. You can find x and y just by multiplying first equation by 6, second equation by 4. You can cancel that x and you can find y. Then you can find x. That is called algebraic equations. Suppose if it is a differential equation, how it looks like? dy by dt equal to ay plus b. This is a differential equation of first order. In mathematics, they will give like this. dy by dt equal to ay plus b. Solve the differential equation, they will ask. Solve the differential equation. So here, solving this can be done in two ways. One is called by time domain method. Another one is called by using Laplace domain. Laplace domain. Have you studied Laplace transform? Where? Now you are studying. Okay. So here we are going to use the Laplace transform to solve the very simple. Laplace transform is very simple. Don't worry. You need some formula, you should remember, and you have to apply and you have to solve. So now let us use the Laplace transform to find the solution, transient response. Because if you apply Laplace, the differential equation becomes algebraic equation. What is Laplace transform? Suppose you want to find Laplace transform of f of t. What is that? Integral of 0 to infinity. In mathematics, you will write minus infinity plus infinity. What you are writing? 0 to infinity, f of t dt. That's all. If you integrate this, the entire function becomes in terms of s. The entire function becomes in terms of s. So, if you apply this to a differential equation, it becomes algebraic equation. It becomes algebraic equation. For example, you in +2, you might have, you are not allowed to use calci, no? You used to logarithmic table. If you take a logarithm of a number, the multiplication becomes addition. Multiplication becomes, suppose you want to multiply 4 and 12. Take logarithm of 4, take logarithm of 12, add these two, then take anti-log. That is multiplication of two numbers. Multiplication of two numbers. So if you linear domain to logarithmic domain, if you transfer linear domain to logarithmic domain, the addition, multiplication becomes addition. Multiplication becomes addition. So if we change the domain from linear to logarithmic, the multiplication becomes addition. Similarly, if we transfer from, if we take Laplace transform of any equation, it is in differential domain to algebraic domain. It transferred from differential domain to algebraic domain. That is the advantage of using Laplace transform. That is the advantage of using Laplace transform. For example, let us take that equation and find the Laplace transform. Before that, let us, what is time now?